Hey, welcome everyone. We're live, period 7-8, learning about logarithmic functions. Today's topic switches over to what is I consider to be the inverse of an exponential, which is called a logarithmic. Their inverse is both in the way that you'd write them, which I'm going to show you here in a second, and then also their graphs are a little bit different. But we're not talking about any graphing today. The big takeaway from today is that you know how to change from one form to another. So whether it's exponential to logarithmic form or logarithmic to exponential form, if you can change from those successfully, you should be pretty good with this. Right here, highlighted, is really what you need to know. And again, if you could do this, then you'll be pretty successful. Y is equal to b to the x is what we've learned. Log base b, okay, that's a subletter. So log base or log b to the y is equal to x. Okay. So that is how you set up a log. Okay, y with the base of b to the y. I'm going to show you how to switch back and forth. We've got a couple of different examples of each, and then I've got a couple of different examples on how to solve them as well. So let's take a look at this. Just as a reminder, as far as this is concerned, you don't really need to worry about it quite yet. But if you do end up with a negative exponent in this, it'll create an undefined log. I don't show any examples of that, though, here. Write an equation in logarithmic form. First thing that I think I'm going to do is, now that I have this formula that's highlighted, is I'm going to label everything as y, b, and x. So y, b, and x. The reason I'm doing that is because if you look at my log formula, now I can rewrite as log with my base of 3 to the 729 is equal to 6. And that's all I'm doing right now, is I'm just trying to rewrite those problems into log form. I'm not solving for anything yet. We're just doing very basics for now. So for instance, in example number 2, again, I'm going to label each of these. This is b, this is x, this is y. So log of 10 to the 1 is equal to 0. Or even in example 3, b, x, and y now becomes log base 1/2 to the 1/8 equals 3. And if you were able to plug these into your calculator, bless you, you'd see that this log base, or whatever it is equal to that other side. We haven't gotten there yet, though. But I will show you how to plug them into your calculator in some form. All right, switching to now going from logarithmic form to exponential form. I'm going to rewrite the formulas that we had. We're switching over to logarithmic form. And again, you don't have to do this, but I like to label everything so I know what it is. So b, y, and x. And then I can plug it into my equation. So 1/32 is equal to 64 to the negative 5/6. If you want to try 5 and 6 on your own, you can go ahead and do that. You don't necessarily have to follow along. Just make sure that you're getting those answers with me. Those of you that later on watch this video, you know you can fast forward and pause and do all that kind of fun stuff. So 27 is my y, and then 9 to the 3/2. And then 81 is equal to 3 to the 4th power. And again, if you checked any of these in your calculator, they would make sense. They'd be equal to that other side. Specifically, example 6, many of you know 3 to the 4th is equal to 81. Like, they work out. So I promised you just a little taste of how to plug them into your calculator. I'm going to show you how to do it with this one that's an exponential. We're going to change it to log form. One of the big reasons that we do change exponentials into log form is whenever they don't have the same base. So just to preface, one of the earlier lessons that we learned was something like 4 to the x is equal to 16. And then we said, okay, well, 4 to the x, and then 16 is 4 squared. And then we were able to solve for x is equal to 2. But if you look at example 7, there's nothing that 2.3 is going to make that's going to give us a 10 base. So that's why we have to use the log in order to move things around a little bit. So I'm going to switch. I'm just going to label this. This is my b, my x, and my y. So now I have log base 10 of 2.3 is equal to x. Okay. Now in this lesson, give it a second here. In this lesson, I just want you guys all to know that the log button does logarithms with a base of 10. So you don't have to plug in any base into your calculator. There's no work for that. If your base is different than 10, if your base is different than 10, at this time you can't really do much. You can plug it in. That's a later lesson. I think that's a little bit too much for today. So we're just kind of go with this. So on your calculator, there should be a log button. So you'll hit the log button. You'll type in 2.3, hit enter, and there's your answer. Now, for the sake of this problem, we're just going to round to the fourth decimal. So 0.3617. So x is equal to 0.3617. And then that's that. Okay. Questions at all on how to plug it into your calculator? Again, just hit the log button, just plug in the number, hit enter. You should be good. It only works whenever you have a base of 10. For now, I'll show you how to do it a little later on. It'll if we get to it in Algebra 2, it makes your life a little easier. All right, converting to solve. I've got 3 problems for you, and this will pretty much be it. For each of the following, we need to find the value of the variable. So what we're going to do is we're going to take the log, we're going to switch it into an exponential form. If you want to try that on your own, you can. But we're going to switch it into an exponential form, and then we'll end up getting whatever our answer is for that variable. So again, we're going to be using those formulas. Let me write them here for us. We've got log base y is equal to x. And in this case, we're changing it into y is equal to b to the x. So this is my x. This is my b and my y. So 2 to the r is equal to 1. And hopefully you guys know that anything that is equal to 1, any number to the what power gives you 1? 0. Good. So in this case, r is going to be equal to 0. Again, anything to the what power will give you 1. That's going to be anything to the 0 power. So now looking at example 9, again, for the sake of our lesson, I'm just labeling everything. You do not have to. It's not a requirement, but it is a nice feature. So we'll have b to the 1/2 is equal to 9. Now, if I want to eliminate a fractional exponent, remember that this is really like saying that I have the square root of b is equal to 9. In order to eliminate that radical, I can square both sides. So then I end up with b is equal to 81. Again, fractional exponents become radicals. Or you could multiply, if you've got a fractional exponent, you could just multiply by whatever that reciprocal is in order to eliminate it on both sides. And then that should give you your answer. Just for those of you that don't understand exactly what I'm saying here, is if this is another way to do this, you don't have to write this down. But I see that I've got a 1/2 here. Okay, so let's multiply this by the exponent of 2 on both. That way those will cancel, and I still end up with 81. It makes your life a little bit easier for those types of problems. Last example that I have for you today. Again, I'm going to label everything. So my 3 is my x, well, mislabeled. 7 is my b, d is my y. So I'm going to have d is equal to 7 cubed, which then in this case, this is a nice one because you can plug that right into your calculator. 7 cubed, I believe you should get 343 for your answer. And that's all I've got for you for today's lesson.